Good morning, dear students. Today we're going to start with a new chapter, which title is Earthquakes and Terrestrial Globe Structure. At the end of this video, you are supposed to define earthquakes, determine the origin of earthquakes, locate the seismic focus and epicenter, recognize that the seismic waves propagate in all directions. You have to define the magnitude of an earthquake, and finally recognize Richter's scale. Now, if you please, you have to prepare your biology book, page 102. Prepare your booklet and open on worksheet 18, and if you please, prepare a draft to take some notes. First of all, I want you to make a simple experiment. So if you please, make sure that your hands are dry and then follow the instructions to see what will happen with you. The first step to be done is to press the palm of your hand flat together as much as you can. And while you're doing that, try to slide them past each other. Most probably, they will not slide smoothly unless your hands are wet. Most likely, your hands will remain stuck until they suddenly slide a few centimeters, then stop. This is exactly what happens in the Earth crust. This is the way movements in the Earth crust take place. Before starting with our activity for today, and which is about earthquakes, let's have a look on our planet. It seems to be peaceful and quiet. However, it's not the case. Because if we take a closer look, you will notice that the outermost layer of the Earth, and which is called the crust, is not of one piece. The crust is of different pieces called plates. Let's have a look on the plates. Here are the plates, and they are just like jigsaw puzzle. However, they are in continuous motion, and this motion leads to many natural phenomena like volcanoes, earthquakes, and faults. Now, if you please, keep your eyes on the boundaries of these plates and see how faults, for example, are distributed. So, you will notice that the faults are mainly present at the edges of these plates, at the boundaries of these plates. Similarly for earthquakes, let's have a look. So, earthquakes are also distributed at the boundaries of the plates, where faults are also present. So let's start with the fact that inside the Earth we have an internal activity, and this internal activity has external manifestations, which are natural phenomena like rock deformations, including faults and faults, and we have another natural phenomenon, which is the earthquake. And today we will start with earthquakes. The first question to be posed is, what is an earthquake? So here is the title of our activity, Earthquakes and Seismic Waves. And now we are interested in giving a definition for earthquakes. To do this, if you please, have a look on this media and try to use your own words to define an earthquake. So if you please pause the video and think about the definition of an earthquake. First, I want to clarify a point about the name of the earthquakes. Earthquakes can also be called seism. A seism is a term which is derived from a Greek word which means shaking. Second, and concerning the definition of an earthquake, we can define it as a series of more or less violent and sudden shakes of the ground. So you have to memorize the definition of an earthquake, and which is the first objective for today. Third, an earthquake can cause different features on the surface of the earth. And we actually have a variety of features, and this variety depends on the intensity of the earthquake itself. So sometimes you can see some cracks in the buildings, in the wall of the buildings, or cracks in the roads. Other times you can see collapsing of bridges, and if the earthquake is a very strong earthquake, you can see a complete destruction for the city. Now, if you please, you have to pause the video in order to read a paragraph present in your book about an earthquake and some features of this earthquake. And now let's move to a new point, which is about the origin of the earthquake. What is happening inside the earth so we get an earthquake? To answer this question and other questions, you're going to watch a video. And while watching, you have to look for some answers, which are for the following questions. Note that you may need to repeat the video more than one time. So, if you please, take into consideration these questions and look for their answers. The questions are about the events that happen inside the earth so an earthquake occurs, the points, focus and epicenter. What are these points? The definition of seismic waves and the direction of their propagation.
An earthquake is violent shaking of the Earth's crust. The Earth's crust is a hard outer covering made up of many pieces called tectonic plates. These plates are always moving. However, the motion is very slow. In a year, they move only 2 to 5 centimeters.
My hair grows faster than their movements.
Absolutely. Mostly when these tectonic plates move, they brush against each other without causing great damage. However, sometimes they get stuck and cannot easily slide against each other. But the plates still keep pushing, thus creating pressure. Eventually, the pressure builds up so much that one of the plates suddenly moves above the other, or they may crash into each other, causing the crust to shake violently, thus creating an earthquake.
The place below the Earth's surface where a sudden dislocation of rocks occurs is called the focus of an earthquake, or the Epicenter. It can be situated at a depth varying between several kilometers and several hundred kilometers. On the other hand, the place on the surface directly above the focus is referred to as the epicenter. The energy released during a dislocation is transferred through the crust and on the surface in the form of vibrations, referred to as seismic waves. It is the shock waves that can be observed as earth tremors, which are most intense at the epicenter.
Starting with the events that take place inside the earth, so we get an earthquake. The first point to be mentioned is that we are at the boundaries of two plates. And at the boundaries of two plates, we usually have faults, no matter what the type is. So it could be a normal fault with divergence motion, or inverted fault with convergence motion, or a strike-slip fault with a horizontal motion. Because we have two blocks and these two blocks are in continuous motion, we have a force exerted at the plane of the fault. the force starts to accumulate until this stress or this force can overcome the friction which is between the two blocks. Once we overcome this friction, a break happens at specific point, and once we have this break, the stored energy will be released. So this is the fault plane, and for example, this is the point where the break takes place and the energy starts to spread. The energy which is spreading out of this point, we will talk about it later, the energy is going to propagate in the form of waves. So you can see the waves coming out of this point, and these waves propagate in all directions. So we have a break somewhere right here, and the energy starts to spread in all directions. These waves or vibrations are called seismic waves. And now what about the focus and the epicenter? These 2 points, let's start with the focus, which is present along the fault plane, and then we will talk about the epicenter. Starting with the focus, or what is called the hypocenter, it's a point on the fault, it's on the plane, where rupture or the break occurs, and the location from which seismic waves are released. So this is the point where we have a break, releasing energy, and the seismic waves start to come out. This is the origin of these waves. Now let's move to the epicenter. Epi means above, so it's above the center. It's a point on the Earth's surface. Yes, it's on the surface, located just right above the focus along a vertical line. So it's located on the vertical line leading to the focus, and where the intensity of the earthquake is highest. Maybe because it's the closest point to the focus, the closest point which is at the surface. And now it's time to pause the video in order to answer some questions. And finally, let's move to the last 2 points which are required for this activity for today. These 2 points are related to the magnitude of the earthquake, which is a characteristic of an earthquake. And the second point is about Richter's scale. What is the relation between these 2 titles? We will discover this now. Starting with the magnitude of an earthquake, it's an evaluation for the energy liberated or released at the focus of an earthquake. So if we have this figure, here is the focus, here we have a releasing of energy. The amount of this energy represents the magnitude. Here I have to give a note concerning the position where I stand. If I stand right here or right there, it doesn't affect the magnitude of the earthquake, because we're talking about the energy released right here. My position may affect another characteristic, which is the effect of the earthquake or the intensity of the earthquake. Yes, it varies according to my position. So if I'm standing at the epicenter, it's the highest. If I'm moving away of the epicenter, it starts to decrease. But in this situation, when we talk about magnitude, it doesn't vary if I stand right here or right there, because we're measuring the amount released at this point. So how can a magnitude vary between 2 different earthquakes? Why some earthquakes have low magnitude and other earthquakes have high magnitude or higher magnitudes? The magnitude depends on the fault length, the length of the fault. This is the first variable, and it depends also on the importance of displacement, whether we have a simple slight displacement or a significant displacement. So these two variables affect the amount of energy and thus affecting the magnitude of the earthquake. What about the Richter's scale? It is used to express the magnitude of an earthquake. So here is the relation. If I want to describe or if I want to express the magnitude of an earthquake, I have to use Richter's scale. So let's move to Richter's scale. So this scale expresses in figures the seism's magnitude. So we have, for example, 2, 3, 4, 5, 6, 7, and 8 and 9, so it extends over 9 degrees. So if I read right here, for example, degree 2 usually not felt. So if an earthquake of degree 2 according to Richter's scale, you will not feel any shaking. For example, let's talk about a stronger magnitude. If it's 6, for example, it may cause major damage in a populated areas. So this is Richter's scale. The last note about the scale is that when I move from one degree into the other, so each degree corresponds to a magnitude 10 times greater than the previous one. So this is everything about the magnitude. This is everything about Richter's scale. This is everything about earthquakes. Now you have to solve these questions. And thank you for your attention. Now let's make a summary for everything. An earthquake can be defined as a shaking, a sudden shaking that happens in the ground. The origin of the earthquake is a sudden break that happens between two plates at the level of a fault. And this break releases energy. This energy is released from the break, and the break is at a point which is called focus. Right above the focus, at the Earth's surface, we have another point which is called epicenter. Once the energy is released from the focus, it propagates in the form of a wave, and these waves are called seismic waves. These waves propagate in all directions. The amount of energy released at the level of the focus is the magnitude of the earthquake, and the scale which expresses the magnitude is Richter's scale.